All right, ninth graders, you can pull out page 86 from your math binder. It is called rate of change. So pull that page out. We are going to start going over that one together. Okay. For each representation given, do the following. First, you are going to determine if it is linear or exponential. If it's linear, you're going to tell me the constant rate of change. And if it's exponential, you are going to determine the change factor. So let's start with number one. And before I even go to number one, let's put a couple notes in the margin. We are first going to, red and blue, we're going to talk about this constant rate of change. So let's write down constant rate of change. Whenever you hear the term constant rate of change, it is going to be talking about linear. You're going to have a linear function. And you are going to either see the letter M because it's the same thing as slope, or you are going to see the letter D, which we use through our whole sequences unit. Okay, so those are the two letters that we will sometimes refer to with our constant rate of change. When you see the term change factor, that word factor often means a multiplier. So a change factor is going to go with an exponential function. And you are going to see the letter R. That's our constant multiplier. That's from our arithmetic versus geometric unit. Okay, so let's look at problem number one. It's asking you to determine if it is linear or exponential, and then you're going to find the constant rate of change or the change factor. Okay. Oh, I have it backwards. Constant rate of change I had done in blue, and the change factor I had written in red. Trying to get my colors straight here. Okay, so on number one, I want to find the constant rate of change or the change factor. If you look at this, I can go back to that page of notes we did the other day where we said if you have an equation and there are no exponents, it is going to be a linear equation. So on number one, I know, first of all, that it is linear. Actually, I'm just gonna put that right here. A, it is linear. So for B, what is my constant? Yes, you have to write it. Rate of change. Okay, well, I have to find the rate of change. You might be tempted to write 2 because that's in front of x, but this is actually not in slope-intercept form. I need to undo that 3 in front of y. So I'm going to divide every single term by 3. And when I do that, I get y equals 2/3 x, and then 9 divided by 3 is 3. So here is where I see my slope, my rate of change. So my constant rate of change, I would say, is 2/3. Yes, I'm going to leave it in fraction form because if you divide that, you're going to get a repeating decimal, which I don't even want to mess with rounding. Okay, look at problem number 2. This is clearly set up as an exponential function because we have those exponents. So I'm going to start part A saying that this is exponential. Now, if you remember back, we always put that rate, that R value, underneath the exponent. It was always the thing directly under x. So right here, that would be 3. So B, my change factor, is 3. Okay, number 3, clearly it's exponential. I can see that curved graph. So I'm going to start number 3, part A. I will say exponential. Now, if I look at this, sometimes people have a little bit of trouble figuring out what's being multiplied. So let's find a couple good corners. This first corner starts at 1. Do you see how the next good corner is up 2 spaces? So I went from 1 to 2. That looks like I'm multiplying by 2. Let's see if that pattern continues. The next dot goes up to 4. So I'm up 1 space, then I'm up 2 spaces, then I'm up 4 spaces, and the last one is up to 8. So every single time, and I want you to actually write this on the right side, you're always multiplying by 2 over here. Since I'm multiplying by 2 toward the right, I'm going to say that my change factor is 2. Okay, let's look at this table. On this table, what the heck is happening? Well, I go from 23 to 5, and that is subtracting 18. I want you to keep drawing in your swoops and figure out all the rest of this subtraction because I want you to figure out what sort of pattern. Well, we can start by saying it's linear because I can see that this is subtracting. You can't multiply to get to 5 and then multiply to get negatives and keep going with the negatives. So push pause really quick, see if you can fill in the rest of your table and figure out what the constant rate of change would be. All right, so we know it's linear. I look over here, it's subtracting 18, and on this side, it's adding 2. From 5 to negative 13, it's also subtracting 18, and over here, it's adding 2. From negative 13 to negative 31, we subtract 18, and over here, we add 2. And then lastly, we subtract 18 and add 2. So for part B, our constant rate of change, I just noticed that I forgot to switch to blue, even though this was linear. Our constant rate of change, you might be tempted to say that it is negative 18. That is wrong because it's not going down 18 every one time. It goes down 18 every 2 times. Reduce that fraction and we get negative 9. That is our constant rate of change. So it's always our change in y in the numerator, our change in x in the denominator. Always draw on those swoops. I want you to see if you can finish up problems 5 and 6. Push pause, and we'll check in with those in just a moment. Okay, on number 5, it's a straight line. So I know, first of all, that this thing is linear. So now I'm going to find the constant rate of change. Okay, if I look at this graph goes, let's zoom in a little bit. This graph is going down 2 spaces to the right 1, down 2 to the right 1, down 2 to the right 1. So how would I write that as a fraction? Well, I would say down 2 to the right 1, negative 2 over positive 1. And that would give me negative 2. So my constant rate of change is negative 2. Negative 2 over 1, which is just negative 2. Let's go to problem number 6. On this one, that would be subtracting quite a bit and then subtracting less and then subtracting less. So I know this is not going to be a subtraction pattern because this has clearly got division going on. To go from 6 to 2, I have to divide by 3. From 2 to 2/3, I'm also dividing by 3. So my pattern here is dividing by 3, which is also multiply by 1/3. Multiply by 1/3. Multiply by 1/3 and multiply by 1/3. Now over here, this is always increasing 1, which is what we want to see for an exponential. If it wasn't increasing 1, then we'd have to figure out exactly what was being multiplied to increase every 1. And we'll look at more problems like that moving on later. But for part A, we will say that this is exponential. For part B, we can say that our change factor is 1/3. Okay, I'm going to put together a little table at the bottom where we have a way to find everything we need for rate of change and change factor on these problems. So let's start with the linear side, how to recognize different functions and their change. So when it is an equation, what you are looking for in an equation is you are going to start like we did up here. You need to solve for y first. So I'm going to say solve for y. Once you solve for y, then you are going to find slope. And remember, your slope is just the m value. It's in front of your x. Y equals mx plus b. This guy right here. directly in front of x, so that is going to be a constant rate of change. Now on a table, whenever it's linear and you've got a table, you're going to figure out what's being added or subtracted and what's being added or subtracted on the other side. Because to get it, you have to do your change in y divided by your change in x. So I'm going to write that out as a fraction. Change in y divided by change in x. And you always start by drawing swoops. I know it sounds so silly when I say swoops, but you draw your swoops on your tables, and that's for either kind of table. You draw on those swoops. Okay, on a graph, how do you tell the rate of change in a graph? Well, you look at the rise over run. This one was going down and to the right, but it'll always be either up or down for your rise, and then right or left for your run. So again, I'm just finding the slope there. All right, let's look at your exponential side. When you have an equation and it's exponential, well, you're just looking for the number directly below the exponent. Whatever number is directly below the exponent, that x up there, that is going to be your change factor. On a table, you draw those swoops and then you look for multiplying pattern. And then lastly, on a graph, you're looking for the distance between those points. Again, you are going to look for multiplying pattern from point to point. Okay, this is going to be a very important page of notes. It's going to help you find your change factor and your rate of change, which is a homework assignment that you have tonight, I think. Don't quote me on that. All right, good luck. Let me know if you have any questions.